Hi guys, welcome to Dogen Sprint 19 demo. This time I'm just going to do the demo using OBS instead of before where we used to record and then use PTV to assemble the demo. So it's all just going to be done one take, mainly because we've been using OBS for the streaming of coding sessions and that seems to have worked out okay. It does mean though that we're going to be experimenting as we go along rather than a slightly more polished everything is ready sort of kind of demo. But hopefully we'll still get the same kind of result at the end. So in terms of Sprint 19, so there's a lot of stuff, as you probably noticed by the release notes. This is one of the consequences of having taken such a long elapsed time between sprints. Though in terms of worked hours we only clocked about 87 hours or so. But it's very varied, I guess you could say that. So what we'll do is we're just going to go through the user visible changes. One slight change that I've done, it's probably worth mentioning actually, is I've created a demo project and I've pushed this to GitHub, though I don't really expect anyone else to use it. So this project is now designed to do the demos. Hopefully that will make it slightly more sensible than the previous make things up as we go along. So as I mentioned, we added in our release notes, we added support for fallibility overrides. So if we look at our demo models, so let me just describe quickly how the demo project works, so to give you a bit of context. So we created 3 models, these 3 guys here, and on the main model, which is the target model that we are interested in for the demos, we've created a number of types with a number of meta types, mainly just to show you what's available. Interestingly, we set this to RM value. That's not really needed for the demo, but that's fine. So our types cover sort of a range of meta types to give you a flavor of what's available. It's not very exclusive really, but just to make sure people don't start to think that you can only do classes. But we're not actually trying to cover this as part of the demo itself. It's just to give you visibility of it. Then we created a second model where we copied some bits of the Dogen profiles just to make our life easier. In the past we've been creating some very simple profiles. I thought I'd use a fairly realistic one again to give you an idea what you can do. And finally we have a third model that's literally here just so we can do references. And that's kind of the gist of this sort of demo model, or demo product, should I say. So going back to what we're trying to demonstrate here. So this variability overrides that we have now, in the past, instead of actually setting the variability, as I explained in the release notes, instead of actually setting the variability directly into each of the modeling elements, we created the notion of profiles. And the profiles enable you to model the configuration, as we do here, and then you can just reuse this wherever you are. So for example, you could, if you wanted to, you could take one of these profiles, such as this guy here, and you could apply it to a modeling element. So I could just say this guy here. And because we are already referencing the model for the profiles, which is the second model as I mentioned, if I now go and generate, let me just first show you that there is nothing in Git. So if I just, let me just say whatever changes have been made. So the change that we've done here, as you can see, is we changed the stereotype of that modeling element. So if I now go to a shell, which we conveniently have here, and if I enter the projects directory, just clean things up a little bit, and let's say I look for the last time I ran Dogen, and presumably we changed the first model. Okay, so if I just run this, okay, so the first thing is we get a stereotypes are not valid. The reason why is because we refer to stereotypes not directly by their name, but by their label. And this stereotype hasn't got a label. So if I just take one of these guys here, they don't seem to have a label. Okay, so we can refer them by their names. We just have to make sure we refer them by full name. Um, but normally this is not ideal, because normally if you're in a model you don't really want to be putting in a complete name for a profile. So we created a notion of aliases that enable us to do that. What I'll do is I'm going to have to go off script slightly here. I'm just going to go and grab from the Dogen profiles one of these labels that we use, and then return back to the demo itself. So as I say, the reason why we use these labels is just so that we don't have to type in a full path to a modeling element. So for example, if I call this test all facets, and if I now go back to our shell, okay, interestingly enough, it seems to be referring to a test marker, which also we don't have. This is the joy of the slightly more unscripted demos. Our area is a test marker, and let's just double check that we are calling test marker by its name, and of course we're not, because this was copied from somewhere else. So now if we call this seconds model dot test marker, hopefully the demo gods are going to be with us this time around. Okay, cool. So just to recap, because we did a lot of jumping here, all we're trying to do there was to demonstrate that nothing stops you from, in a given model, from using a profile to configure the output for a given class. So in this particular case, for a class, we said, please use the profile test all facets. And we didn't refer to that profile directly by its name, but we referred it by its label, which, as I explained, is how we normally tend to refer to profiles when we are referring to them in model elements. Now, because of this, the nature of this profile, what we'd expect to see now is we expect to see a lot of generated code. And as you can see here, we're now generating a lot more code now, basically all facets. So we're generating some tests, which I thought we were already, to be fair, some I/O, some test data. Oh, actually, sorry, these are files that got modified. So in effect, because we were already generating pretty much all of these facets, we ended up actually just changing the marker, because you see here we're referring to the marker test marker, which is this guy here, and that's different from the marker that we're using, which is the default marker. So that's basically how we use profiles, as it's always been. Now the problem we had to face with this release was that we wanted to generate models in two different ways. Just put this on a pause for a second. Seems to be some activity going on. Okay, let's resume our demo. As I was saying, the problem we were trying to solve was the fact that we wanted to build the exact same model in two different ways. One way was the normal way, is in other words to generate just about the right amount of facets and so forth for a given model for the purposes of that model. But the second way, as we explained in the release notes, was to try to generate as many facets as possible, so that we'd use this to test Dogen to make sure things working. And so for this, we couldn't rely just on making changes to diagrams, of course, because we wanted the same diagram to be generated with two different configurations. So the idea that we came up with was this idea of overrides, where we can actually override any of these metadata elements and anywhere in the diagram. But particularly, really, or the one we cared about was just the default, the profile applied to the model. So the idea then, of course, is that you can supply different command line arguments, and that then results in these overrides being applied. So what we'll do is, let me just regenerate this again so we can see that everything goes back to where it was. So what we'll do is we will just jump over to our README, where I already saved the required command line, and then we'll just apply the override here. And then, as you can see here, we have a variability override, and then we have in fact, let me just, before we do this, let me just show you what the documentation is for the variability override. So as you can see here, the variability override takes a CSV string. In fact, as you can see here, there's a slight bug which we've already fixed for Dogen 20. So it takes a CSV string, and this CSV string contains the model name, the element name, and the attribute name. These are optional, and then a key and a value. So if you go back to where we were, clear this up. Now we are not supplying anything with this model, with this sort of invocation. So that basically means that will apply to all models, and it expects you to then basically choose a specific modeling element metadata type. So in this particular case we chose profile, which exists at the model level. So as you can see here, this is the configuration for the model, and there's the profile. So we will just generate them. Oh, apologies, I think I deleted a bit too much. What I meant to say, something like this. Right, now then, so the overrides kicked in. Now as you've seen in the previous generation, the overrides here are going to do different things depending on the types. So in this particular case, you can see it generated a lot more stuff now. We have solutions for Visual Studio, we have hashing that was not enabled before, we have lexical cast, and all sorts of other things coming through. And that's due to the override. If I take away the override, then of course we're going to resume to the previous state. We still have this autosave here, we probably should save. And so this override enables us to determine, to affect, I guess, the code generation. It's the second model that we modified. To affect the code generation externally, I guess, without actually changing the model, which was really useful for this particular case. Now, we've implemented it in a sort of a generic way, so you're not limited to only affecting the profile. So, for example, say I would like to, I don't know, enable C# perhaps. I guess this model is more or less compliant with the two languages, though of course the target model is C++, so I don't think that's a good idea. Let's see what else we could do here. Could add references. Well, pretty much you can do anything. You could override any modeling element here. For instance, let me just explain with something else that's slightly less complicated. Let's say I take the modeling element A class in the first model. So if I just say something like first model, so this will only apply to first model, and the modeling element will be A class, and I'm not entirely sure if you have to prefix it with the model name. We'll see that. And then again, I'm applying just that one profile to this modeling element. So if I now have a look at Git again, interestingly, it doesn't seem to have latched on. So let's try that with the model name. So Dogen is telling us they couldn't quite apply this override. So presumably we must have been able to apply the override first time round. Interestingly enough, we don't seem to see any differences after applying the override to the class. I'm not clear why that is. Let's think about this for a second. So, trying to test all facets. It should have resulted in the... I wonder actually if the problem with this is that configuration overrides probably, in fact this might be a bug, configuration overrides are probably being superimposed because when we apply the overrides, oh no, actually no, that's not quite right. We applied the overrides prior to applying to expanding profiles and configuration, so actually this should have worked. Okay, let's try something slightly different. Let's just call these that. No, not entirely sure. To be fair, this should have worked. Not entirely sure why not. would have expected this to have done exactly what it did the first time around, when we manually added the stereotype to this class. Okay, sorry, now I'm just being a bit silly here. Let me just explain what just happened there and why that would never work. So remember, what we're doing, this is actually quite a good teachable moment, I guess. What we're doing here is we are doing a variability override of a specific key against a specific value. Now, if you see here, the key they're applying is MASD.variability.profile, which is a key that only makes sense for models. It doesn't make sense for modeling elements. This is just a property of a model, not a property of a modeling element. So therefore, you could override this key and it would just do nothing because this profile doesn't get applied. So you'd have to choose some other key that actually belongs to a modeling element that does something. The way we tested this was actually by seeing the keys coming through. We didn't actually test the impact of the key once it was generated, so that's why I can't think of a good key to affect a specific modeling element. But just for your knowledge, it is possible to update modeling elements this way. This was variability overrides. One other additional feature that we added to Dogen is the tracing of model dependencies. So for this, we'll just resume our help screen and just grab all the tracing stuff we got here. So tracing enabled. We should have probably done this prior to the demo. Tracing level. Put on detail on this. Tracing formats, which we'll play with to demonstrate. And the tracing backend. So tracing backend actually is not just yet used. It's there because we are working on this with the relation. It's not used at present, so we'll ignore that for a second. Right, so what we'll do now is we're going to generate this model without the variability overrides because we've already played with that and you've seen how it works. So, and the tracing format will just start from the beginning. Okay, so as usual, when we use tracing, first thing happens is we generate a byproducts directory. So if you just hop over to the byproducts directory, you can see here the tracing information. So the references graph is what we're particularly interested in, and what this gives you is a dump, a textual dump of the references in this model. And in this particular case, the reason why we always have a text version is in case you're somewhere where there's no Emacs, no PDFs, and nothing that you can quickly use. You can always rely on text being available. But this is not our preferred format, really. Our preferred format is always going to be org mode, because we do a lot of things with org mode. And of course, if I could type would help. And the good thing about org mode is it just gives you sort of an interactive, I guess, sort of view of things. And this is a very, very small graph. If this was a Dogen model, you'd have many, many models here. And so filtering and searching and so forth are actually quite useful functions. The third view you can have with this, which is similar to transforms, is graph viz. And for this we need to do an additional step, which again we probably should have put in our notes. But we'll try to do it from memory. So there's the references graph, and if I just do something like .-t pdf file name, I guess, -o, and this should then generate a PDF. And then if you open up that PDF, it gives you a graph view. I mean a graph is in the sense of a graphical view of the graph of the references. Again, this is very useful for when you got really complex graphs, because it shows you sort of how well you're doing in terms of modeling, or whether you've just come up with some really mega complex model. And that is this feature, really. Let's return back to the shell. So moving on to the next feature. So we've split the generated tests and the manual tests. So what we've done is, and I'll just demonstrate this by just showing you the code that we've got at present. Let me just enable IDO mode, which for some reason seems to be disabling itself. If I take any of these models, you see that the tests directory that we used to generate in the past has been replaced with the generated tests. I mean, you're still free to, of course, create a test directory, but inside the generated tests, all we have is the generated tests, the CMake files needed to get those generated tests to compile, and the tests themselves. And these aren't changed, of course, as we were before. And the main rationale for this was that we didn't really want the mix and match that we were doing before, because once we've moved over to the variability overrides of profiles, it was getting really complicated to get things to work both for manually generated CMake files and automatically generated CMake files. And in the end, that actually led us to the conclusion that it didn't make a lot of sense to pollute everyone's products with generated tests, because really this is more of an exceptional case. We just want people to, in some kind of circumstances, run the generated tests to validate that the models are correct. But most of the time, users are probably not going to make use of this. So it's a good idea to hide it away, I guess. So this was the splitting generated tests and manual tests. So the metadata keys are processed in inverse order. So what we'll do is, I'm just going to travel back in time to demonstrate this feature, and that's let's make sure first we'll just ignore this. Now that we have you see here IDO disappearing again. Now that we have our demo project in Git, we'll try to keep it tidy. So ignore my products directory, and here just cosmetic changes to our diagram, I guess. Models, cosmetic changes to diagram. Okay, so now we're in a good place. What we'll do is we'll just jump over to our root shell here, and then in the root shell we will just uninstall. So apt get remove version.applications. We'll just remove current version. Annoying thing of Emacs is this auto-completion sometimes. And we just hop over to the previous version of Dogen. Again, autocomplete not helping. And if we jump over to our shell, just for the measure, let's just make sure we are running the correct version, which is 18. So I'm just going to run the generate for this. Doesn't really matter tracing. We'll just run generate. Okay, it does help if you're in the right directory. So we'll just do the generate, and hopefully what we'll see, again, I haven't actually tested this before, but as you can see here, as expected, two things happened. Now I'm going to ignore this for now because this is part of my next bit that I want to talk about. Three things happened, in fact. So I'll talk about two of those three things. The first thing is you can see that a number of things got deleted, and this number of things that got deleted are actually related to the generated tests. So this is basically, we are now going back to the way things used to be done in terms of tests. And the second thing actually that got done is that we just got these headers here, which I'll explain in a second. In effect, we didn't demo what I expected to demo, which is the order of includes. The reason why that didn't happen is because in our demo project we just don't have enough data, I guess, for this to happen, because there's only two models, and so first model is including the second model. So what we'll do is, just to show this effect, we're just going to create here a fourth model, and we'll save this model in our demo project, which is Dogen demo. And so if I go to projects and models, and if I just call this fourth model, and if I just save the fourth model, and now what I'll do is I'm actually literally just gonna copy the third model and just make a couple of very small changes here, like the names, and well, I think it probably doesn't matter, this class has got the same name. Oh, I just noticed that this is a lot smaller, so let's make like everything else. We use very big fonts here for the demo, so you can see. So now then, if we go to our first model and create a reference here to Dogen MASD.injection reference fourth model, we will also have to generate this fourth model, of course, otherwise compilation will fail. And if we here we just copy the approach and create a D, which is fourth model, another class. Now we should probably have enough data for this to work. So if we just resume editing in Emacs, and what I'll do is first I'll just add the fourth model. Then for good measure we will ensure we have CMake support for it. And in theory we should just be able to build this now because it's just the fourth model itself. So if I just go to the output directory and do a make, well, for good measure let's just call CMake as well actually, because sometimes CMake okay, I think we probably forgot to generate the model. Let's just go back to projects. Interesting, that should have generated the model. Did we misspell it? Oh, we did misspell it, so it's called fourth model. Let's just fix that because that's just going to cause problems. It's good that the error checking is better than we. Right, so now if we try again to resume. Okay, now we don't seem to have any tests for the fourth model, which to be fair is probably about right. Let's just double check. Default profile, and what does the default profile say? Tests.enable true. Okay, so that should have resulted in some tests being generated. Let's just double check that everything's okay with this fourth model. First let's just delete this 4. Right, so it's telling, okay, right, so now we just have to be careful. What we're doing at the moment is we're just mixing and matching Dogen versions, and let me just, before we go any further, let me just go back to the latest version of Dogen, because this is just going to be very confusing. So if I just remove Dogen again, and go back to 19, oh, close, not 18, and so I'm just going to make sure that we are all on the same page in terms of the versions, because I think this is the reason why it's all getting a little bit confusing. Right then, once more, if we attempt now to generate and build, Dogen still does not happy enough to generate our projects where we'd expect. Okay, generated test is coming through, that's good. I think the problem now is, of course, the mixing and matching just caused a lot of problems. I'm just going to start again. This is not ideal, but this is the new world of live demos, I guess. Where perhaps you'll get more confused rather than see the point of the feature. But as soon as I got this working again, we will recap what we're trying to do. Okay, so we still seem to have a problem with our generated tests. As you can see here, generated test is looking exactly what you'd expect. So I'm not entirely sure why Dogen is so unhappy about generated tests. That actually looks very good, very healthy. Let's just look more carefully about the error message. Okay, let's just look at what we're trying to do with this command line. And let's just rm1 as rf star, which is always a good thing to do after a while with CMake once you've lost track of what's going on. Okay, so as you see here, the problem is not at all with the second model, with the fourth model, but the first model. And I think, as before, as I explained before, if you start mixing and matching a bit too much, you're going to end up in trouble. So what I'm going to do is I'm just going to make one slight change here, which is I'm going to get this to where it was and go back to my shell. Try again. Okay. Now, okay, let's just start all over again so you can see exactly what happened here. So all we're trying to do at present is we're just trying to add a copy of the third model called fourth model with the reference. And we're doing this with the correct version of Dogen, which is the current version of Dogen. And then what we'll do is we will just ensure that we checked in everything related to the fourth model. Now I haven't actually generated the first model, which to be fair we probably should, but first we'll commit this. Add new model. Okay, and then what we'll do is now we go to the shell again, and in projects we will just need to regenerate, just as we did for the fourth model. We just need to generate the first model. And again, if we just go to output and we I'm just gonna do both CMake and make at the same time, because just saves us a little bit of time. Okay, now of course in order to build we need to reference the new model, and the first model is not doing that, so here's our fourth model. Okie doke. So now then, hopefully the build will be slightly happier. Can even run all tests. Okay, so we're where we should have been to demonstrate this. So let's just go over to Git and say first model, first model, first model. Okay, first model adds reference to fourth model. Okie doke. So now then, if we resume our demo, so what we're trying to say now is, just to recap, we now have not just one referenced model, but two referenced models. And the order of reference is third followed by fourth. So what you'd expect to see is when you're including these models, you expect to see them in the right order. So third followed by fourth. And so, for example, if serialization is enabled, you expected the registrar to first call the register types for first, third followed by fourth, and so forth. This is not a very good sound for Portuguese people, the fourth. But of course the problem was it wasn't doing that. So then what we're going to do then is we're just going to resume our shell here, and to demonstrate the problem we will well, actually we can just open up a file such as, for example, serialization is not enabled at present. So what I'm going to do is, serialization is a classic case where this occurs, and I know for sure that happens there. So what we'll do is we'll go to our profile, which is here, and we're going to say please enable serialization, and then we will generate all models. Keep moving away from the shell. Should really have two shells here, and we will just going to generate every single model, and hopefully if I just jump over to Git I should see serialization coming through. You recall we still have the tests there, just to be fair we don't really need for now, and we'll see them coming up again in a second. Plenty of serialization stuff going on. Let's just make sure that that resulted in compilable code. It's always a good thing to do, and seems to be the case. Okay, that's very good. Okay, so now then, once again we shall just commit all of this. Now everything we got here is what you expect. So if I just say enable serialization for all models, Now what I'll do is I'm just going to open up our registrar, which is how we noticed this problem in the first place. So if I just go to, I think it might be a header only file, serialization, registrar, it isn't, okay. So if we go to the first model registrar, what you can see here is, interesting enough, LSP is a little bit confused here. But you can see here that we're referencing the fourth model first and then the third model, not the right way around, as I should say. And similarly, we're referring here. Well, actually, because this is sorted, this is not quite representative, but this is the key. We are referring to the fourth model first and then the third model, which is not what you'd expect. Let's just double check the references that we've got. So we referenced third first and then followed by fourth. It's actually not quite what we wanted, because if you think about it, we are using the latest version of Dogen. So at this point this should have been fixed. Most peculiar. Just for good measure, let's see what happens if we change the order and refer to fourth and third. This has definitely this fix definitely has gone in, because we were looking at the log files, and the log files were showing us the order being fixed, but perhaps there's some additional sorting going on here that we're not taking into account. So what happens if you try to change the order? Nothing happened. So presumably what's happening is that it's not, we misremember this, and actually the place where this is happening in is not affected, or at least the registrar is not affected by this. So it's not perhaps a good demo of the problem. But nonetheless, what we'll do is we will just leave this as it was, and we will just leave it as that, and let's just see if anything happens. Actually, it may just be that we can't demo this, in which case we will just have to skip this. But so we now have everything we think is needed to demo this fix. We just need to remove Dogen and go back to the previous version, and let's just see what happens. Now, I'm not going to promise you to be able to see what I want you to see, sadly, because we can't generate the second model, but we can generate the third and the fourth. Of course, in practice, no one actually uses Dogen like this. We use it from CMake, but I wanted you to see in the demo us running Dogen from the command line. So let's just see if this made any difference in terms of ordering. Okay, here we are. So it did make a difference in terms of ordering. However, it's actually showing us the right order. So I think we have two separate bugs. So the previous problem we had was that we were reversing the order of the references in the model, in fact of all the keys, and we fixed that. We were sure, because when we looked at the log files we could clearly see that if things were coming in the right order. However, it seems to me that we must have compensated for that bug by reversing the reverse somewhere in the code, which now results that some places are actually still in the wrong order, because the second reversion is still kicking in. So this is actually quite positive. We have found a problem here. I'm going to raise a story for this next sprint to have a quick look at why this is. But so as you can see here, we're now seeing things in the right order, and this is bad, because we wouldn't expect to see things in the right order with the previous version of Dogen. So clearly there's something else happening in the registrar, which we'll have a look at. Okay, so related to these kind of fixes was also fixing the tracing numbers. I'm just gonna show you what we generated a second ago, and what you can see here is that the tracing numbers are now just basically monotonically increasing. So regardless of what they do, they just go up. In the past, what the tracing numbers did is they went 0, and it was 0 for both the input and the output of a transform. So in this particular case, as you can see here, this is the same transform, so they would have the same number, and then we go to number 1, and then again, if there's an input, it would be input of 1 and the output of 1. As it happens, we found a bug in some corner case where that logic wasn't working. So we changed that now, and it just literally just increments by 1 every time it does a dump. So it's very, very simple, and doesn't really require any logic, any clever logic. So that's the tracing of dump, files. Now let's just, before demonstrating the next one, let's just go back to the right version of Dogen. Or actually, do you know what? For good measure, let's not go back to the right version of Dogen. Let's just show you what happens if the fourth model, which is this chap here, suddenly decided to reference the first model. And if you just call second model here. So in this case, the first model is now referring to the fourth model, and of course the first model is also referring to the fourth model, so we have a cycle. And now if I just jump over to our shell and I try to generate the first model, what do you see? Well, actually worse than that, it's actually worked this time around, but in certain cases you just see some really strange errors, particularly to do with serialization. In fact, it should have also happened here. Let's just double check to make sure we save the model, because we have serialization enabled. Just make sure the first is referring to the fourth. It is, and the fourth referring to the first. It's rather puzzling. This should have come up with an error. This demo is not going exactly according to plan. So we just created a reference cycle, and in the past what this was causing some really strange error messages. I'm not entirely sure why it's not happening right now. What we'll do is, just for good measure, let's just go back to the right version of Dogen. These sort of live demos are a little bit harder to do, really, because whenever there's problems you just have to cope with them on the fly. So if we try to okay, right, so this is good because at least we're also not detecting the cycle now, so that tells me there's something really wrong with this. Right, the first thing we're going to do is just clean everything up here, because like I say, you shouldn't really, once you start messing around multiple versions of Dogen, just have to make sure you're working from the right version. Here's the cycle that we wanted to see. Right, so now we definitely know for sure we started from the right version. Let's just make sure that our references are correct. So MASD injection.reference second model. Okay, interesting. We meant to say first model. Now, for good measure, and because I'm sort of a annoying kind of guy, I kind of like to know when things don't work. Let's just go back to version 18 and see what we expected to see. Right, okay, here we are. So, as you can see here, we have a cycle, and that cycle is actually causing things to be generated more than once. Dogen is clever enough not to get itself into a loop, because it detects that it's loaded the model and it doesn't load it again. But then you get these really strange error messages to do with the duplicates that result in having the same model sort of loaded, well, not loaded, but you know, duplicated. So this was what we just how we bumped into this problem. Now, of course, it took us a while to understand what that error meant, which was quite annoying. So then we thought, okay, perhaps the best thing to do is to detect cycles and to tell users about it. And so now you have a cycle, and it detects the cycle and it tells you what the cycle is. so that it can do something about it. It is also clever enough to detect other variations of the same theme. So if I say, well, actually, I should have left that there, but it's fine. What we'll do is we'll go here, and if I say something like Dogen MASD.injection reference first model, well, this is also considered a cycle, and it just tells you that the model is trying to reference itself. And for good measure, it also detects duplicates, which I think might be a separate story. Okay, so it's the next story that we need to demo. And the reason why is because we kept on sometimes copying and pasting, and then not realizing that we forgot to update what we copied and pasted. So almost always when you have a duplicate, it's because we meant to do something else. So we now detect and let you know about that. So the last feature I believe that we want to talk about is the removal of master headers. So yet again, I'm going to travel in time to our previous version. I mean, we've already seen this master headers a second ago, but even apt is getting upset of so many installations. Right, so if I generate one of these models with the previous version of Dogen, now of course we need to be careful to make sure that we remove the errors, and if I generate the first model and jump over to Git. So as I explained before, tests have been changed to generated tests, so that's what you expect. But you also see these headers here. This is sorted headers: all IO, all SIR, all TD, and all. So all IO, for example, just includes every single file inside of IO, and all SIR, similarly, all files in serialization, and all just includes every single file in a model. Oh, actually, it's all the files in types, which is actually slightly misleading. So I was under the impression that we had a all, but actually maybe I'm wrong. So there's only a all at the facet level. For each facet, it just includes everything in the facet. And then if you want to include everything in the model, you just include these 4 headers, and then we include everything. Now we've removed this feature because originally we only needed it for one purpose, and that purpose was to for manual tests. So we used to manually test generated models, and in those days it was quite annoying having to remember to include headers for 10, 20 types. So we just did that, and then we removed we moved over to generated tests, which made our life much easier. And then the feature was there, but no one was using it, and so we decided to just remove it. And so therefore there is no more these sort of global includes. It's also probably a good idea because we don't really want to make users include big adders. We want people to think about what they're including so that they pay for what they use. Okay, and I think that's about it. So this was a bit of a rambling demo compared to other demos in the past, but it saves us a lot of time because we don't have to do 20 different takes. We never did 20, but 5, I guess. We just do one take. Also, I guess it allows you to see the behind the scenes, how things actually happen around here. But all in all, it was a very good sprint, very interesting sprint, and hopefully the next one will be equally interesting. Thanks for watching.